Koya is a network simulator included with the Contiki NT operating system. It is designed to simulate networks of resource-constrained IoT devices. It's a multi-level simulator where nodes can be hardware emulated using the same firmware that is running on the devices, where it emulates each CPU instruction. But nodes can also be compiled to native code for speed and also implemented at a high-level Java abstraction. We usually use Koya mode, that is compiling the code to a native library for speed. But it's still the same code that we compile to run on the hardware devices. So the code is identical with the firmware code. So here we start by adding a server node that we receive messages, and we can then add any number of nodes that are either positioned in a certain way or randomly positioned in the network. And then we create another node with a different firmware. It's a client that will send information to the server. And in the same way we just select the source code and we create it, and then we can select the number of nodes, and we use random positioning to start with. And since the node communicates wirelessly, it has a simulated radio medium with a certain range. So here we can see the range, communication range, where the green is the range of communication and the grey was how large of interfering. This was just a very simple simulation just to show how it's working in Koya to set up a simulation. And now we load a somewhat more complex simulation where it set up more nodes and the possibility to tell a node to do a black hole attack in the routing network. What we have changed in Koya is added the possibility to save data traces, where data trace is essentially a trace of what is happening in the simulation, so we can go back and get all information from it. We also enhance the API for the simulation script we see in this window. What this script does is it waits for the network to be stable, log it in the data trace that is stable, and then randomly select one node to start a black hole attack. We see here selected node 6 to do it. But we usually don't want to use Koya and run it one by one simulation, and we want a lot of different simulations. So we have scripts here that takes, based on simulation, generate different topologies randomly with different constraints. For example, we start here by just randomly select them, and here we tell them that the node should be at least distance of 40 between each other, which will spread out the nodes more. So, and these are identical simulation except for the topologies. So if we load this, the same simulation, we will see that each has a different topology, and we can also change other properties in the simulation. So based on just one base simulation, we can generate a lot of other simulations with different topologies, different settings. Here we just load the other one that was more spread out. You see, in the first one, nodes could be on top of each other, but by telling them they should have a certain distance, we get simulation of more spread out topology. When we generate all these simulations, we don't want to run them manually. So we have other scripts that can just run them in batches without using any GUI, which makes it easy to run on servers. So what this script is just running Koya until it reaches the endpoint, and the simulation control script is the one that decides when a simulation is has run enough to generate traces. I will speed up this. Once all simulations have been run, we will have one data trace per simulation, but they have unique IDs. If we run it again, we will get more traces. We also have a library to help with parse these data traces. Here we see a summary of the events the trace contains, but normally the raw traces are not that useful, so we usually use other scripts that extract the feature we want to use in the machine learning.